20 minutes or so this is a lot of material in this talk. Thank you for coming. This is COM Under the Radar, Circumventing Application Control Solutions. Who am I? My name is Jimmy Bayne. I am at Bohops on Twitter. I am a security assessor and researcher at BSides. I'm actually from Baltimore, so this is a great venue. Glad to be here. I'm actually an alum of Towson University right down the street, so go Tigers. So if there's any Tigers in the audience, it's awesome. This is my first BSides talk, and actually my first talk in general, so I'm very nervous, but happy to be here nonetheless. I support a couple community projects. I blog at bohops.com, and I actually help Advar Mo with the Living Off the Land and Binaries and Scripts project. All right, today we'll discuss a brief overview of COM. We'll try to keep it short. COM is COM. We'll also take a look at two application whitelisting solutions, and as well as look at a few different bypasses and some defense considerations at the end. After the talk, I'll follow up with a blog post in the event that if I underrun, there'll be information provided there. So let's get started. Okay, so what is COM? COM stands for the Component Object Model. It is a binary interface for facilitating function calls between components. Components are also called objects. A little redundant, right? So functionally, it's really middleware. It allows two or more applications to communicate regardless of the programming language implementation, the underlying OS, but in reality, it's a major part of the Windows operating system. There's some key terminology that we'll use here. There's a concept called an interface. Basically, an interface is a definition for exposing member methods and properties that a caller can actually access through a COM object. A class is actually the implementation of a group of COM interfaces that serve as a template for a COM object. Class metadata is actually stored in the registry with registered COM. An object is nothing more really than an instance of that COM class, and then we use that to access those interfaces and properties to actually manipulate data. So instantiation is really nothing more than the activation of COM object. So that's a lot there. Let's see if we can make some more sense of this. So for registered COM, the registry keys actually direct the activation of a COM object. The metadata is actually located in HKey class's root. That's a registry hive. The data is actually emerged from two other hives, the HKey local machine and the HKey current user. Interestingly, key values in HKey current user actually override values in local machine in the event that if there's any sort of confliction or keys that need to be I should say hijacked. We'll use that, actually we'll come back to that a little bit later on when we talk about some of the application control bypasses. So there's a lot of different COM keys. Some of the most important ones actually reside under this class identifier key structure. A class ID is really nothing more than a GUID with squiggly brackets. That in itself actually represents a unique identifier for a COM object. Underneath this class ID subkey structure, you have server implementations. There are two, improc server 32 and local server 32. Improc server 32 is a DLL, actual DLL or an OCX in-process server implementation. So when it's loaded, it basically gets loaded into the calling process. A local server 32 out-of-process COM server implementation is pretty much an executable. So if you call that, it actually spawns an executable. There is this thing called a programmatic identifier. This is actually a friendly name that we use to call and activate our target COM objects. It would be very difficult to do so by CLSID. It is possible, but for the most part, we do it through the prog ID. There is also a concept called registration-free COM, which is very interesting. It's actually, you can actually register, or it's not really register, I'm sorry, you can actually activate COM objects outside the registry using different manifests, assembly manifests. That's out of the scope of this talk, but it's something to be aware of. All right, so we have an example of actually the key structure here. If you can see at the top left, the COM class ID, that's actually the unique value that represents the COM object. In this case, we have an improc server 32. That key value actually points to a COM server binary path. And in this case, C Windows System 32 wshowm.ocx. And then we have actually two programmatic identifiers here. In this case, the friendly name is wscript.shell.1. A version independent prog ID would just be wscript.shell. So what is this thing with COM instantiation? So we want to use that object. So in order to actually leverage this object, we can use something like a script host, and PowerShell is good for this. It facilitates this. So we can actually call a COM object in PowerShell with the new object commandlet and the COM object parameter. So in this case, we actually will call wscript.shell, the program ID, and that actually gets mapped back to the program ID, the class ID in the registry when it's invoked. The in-process server is loaded into memory, and then the COM object instance is actually created. So from here, we can actually see that we can see the actual members of this particular COM object. And what happens is this is actually that interface methods and properties that we can access through the COM object. What that really means is we have pointers to its interfaces so that we can actually manipulate data and leverage these methods if we choose to. So in this case, at the bottom left, you'll see that we actually do this. We will call the exec method in this context, and we simply just launch notepad.exe. So there is a concept called active scripting, and that's based on COM OLE automation. In Windows, there's two major active scripting engines that expose the respective languages, and that's JScript and VBScript. So a script host is something that it actually hosts scripting engines for running script code. A few examples you might be familiar with are cscript.exe, wscript.exe, msxml 3 and 6.dll, and the script object DLL. A facilitator is a term that I actually made up. You've probably heard things called like lol bins if you're familiar with some of the Twitter stuff going on recently. In this case, really a facilitator is a binary that actually will proxy, say, a script or some sort of script code to an actual script engine. So something like Reg Server 32 or MSHDA is actually calling another script host to run that code. So what does all this really mean at the end of the day? Attackers typically look for ways to abuse COM. One of those applications is application whitelisting. Other things that attackers look to do, defensive evasion and persistence and payload delivery. We'll take a look at application whitelist bypasses specifically a little later on. So here's some excellent resources on COM if you're interested. COM in 60 seconds, Windows System Archaeology, and COM, the Power Thief. These are great researchers. James Forshaw, Matt Nelson, Casey Smith, Rob Maslin. They actually go into COM pretty in depth in these talks. Highly suggest you look at these if you have the time. And at the bottom, if you're familiar, if you're from Baltimore, you'll know what that is. You probably need a few of those to get through some of the COM internals. It's definitely it's definitely a ride. All right, so what is application control? Application control is pretty much the practice of restricting unauthorized code based on some criteria or some set of rules. It can be based on a signing certificate, a publisher, or like file properties like hash or extension, and even file path. The main approach for whitelisting really is three. You can whitelist, you can block, or you can use a hybrid of both. We sort of use the term application control to really mean application whitelisting. You can still have policies that block while others allow. It's colloquially we just refer to it as application whitelisting. In this talk, we'll focus on two of the Microsoft solutions. They're highly available, readily available. We'd pick probably more on vendors if we had access to them. Right, so what is AppLocker? AppLocker is an actually application control solution introduced in Windows Server 2008 and Windows 7 Enterprise. configuring is very straightforward. It's configured through group policy. It supports 2 modes, pretty much enforcement and audit. Rules can be set for executables, installers, scripts, and DLLs. Rule conditions are based on file, hash, path, publisher. In AppLocker, we can actually configure default rules pretty easily. These are really good for testing and baselining, not recommended for actual production because there are evasion techniques, and we'll see that shortly. AppLocker is not actually considered a security boundary. It's actually considered a compliance boundary. And that's important because it does not enforce a code integrity policy. And what that means is that in Windows, there's something called the Windows Lockdown Policy. And the idea is that there are implications where we can evade AppLocker by simply calling one of those script hosts and executing unsigned code. Because in theory, a lot of those are trusted because they are technically signed. So in the screenshot below, we see an effective AppLocker policy trying to call this evil.js file, and it's blocked. And the reason for that is because the path rules are blocking this because it does not allow from that path. The next application control solution is Windows Defender application control. This was actually formerly called Device Guard. Evolution of names, right? Changes every 2 years. So this was first introduced in Windows Server 2016 and Windows 10 Enterprise. It's actually configured with PowerShell commandlets, and it also enforces an enforcement and an audit mode. Rules are, rule conditions are based on rule levels that include file hash, file name, publisher, and a various level of certificate signing. Based on different levels of signing. The default rules can obviously be set, but for the most part, those are very restrictive, so companies should create their own rules in order to customize whatever fits their organization. So WDAC actually enforces a code integrity policy, and that's very interesting, through something called user mode code integrity. And you can set that in the WDAC XML policy that you set for your organization. So under UMCI, and that's user mode code integrity, a system is locked down to prevent the execution of unauthorized binaries, unsigned code, and installer packages. It is considered a security boundary, so if you find a bypass, you should report it to Microsoft. It's very possible that you can get a CD out of it. At the very least, you might make the block rules. So, and below in the screenshot, we have an example of WDAC actually blocking evil.js. So, of course, no talk is complete without mentioning PowerShell. Again, as many of you already know, PowerShell scripting language built for .NET, has COM interoperability, which is pretty cool. A lot of great use cases for development IT. For a long time, it has been abused by attackers. Hopefully that's shifting a little bit more. I think we're seeing more of that. Really great detection optics in version 5, since version 5. Script block logging, module logging, transcription. Obviously, we should all have that turned on and monitoring that in our organizations. It supports a language mode called constrained language mode, and that actually restricts access to different classes, types, commandlets, scripts, and it's very effective when backed by an application control solution that enforces code integrity. Now, that's interesting because CLM is turned on in AppLocker as well, but without the code integrity support, it sort of nullifies it a little bit. Let's start looking at some of these bypasses. This one isn't necessarily COM related, but this is just default rules. I really wanted to drive home this point. These path rules are very open. So you set up default rules with AppLocker. A user who can write to some directory or some path can easily copy that JScript file, like say in Windows tasks, and then run that script. So in this case, we simply pop calc.exe and successfully run our shell code, or I should say scriptlet code. This is probably one of the more well-known attacks. A lot of you defenders out there are probably familiar with this, as well as you red teamers. I call it 50 Shades of Squibbly-Doo because this is originally called Squibbly-Doo. But actually, Squibbly-Doo takes advantage of So this was actually discovered by Casey Smith initially, but it actually uses the runtime script component, and that's the script object DLL. And what's interesting is that you can actually use a script component file, whether locally or remotely, and you can fetch that and actually run script code. So if you see on the in the actual image there, that second block, it's actually pretty cool because that's actually embedded JScript code right there. So if you successfully run this, it actually will go out and create that COM object and run that code. So in this case, we actually do just that. So the bolded, the actual bold at the top block there is a representation of how you can use Redsurf32 to run this unsigned code. With that, there's actually other variants. There are a pub prn.vbs, which is a really cool technique discovered by Matt Nelson. It actually does an injection. Pub prn.vbs doesn't appropriately do sanitization, so just another form of abusing this script object DLL. There's also other variants that you can use through these INF files. I blogged about a few of these last year, probably too many of them, honestly. But nonetheless, other ways to pretty much perform squiggly do attack. The next sort of bypass for AppLocker in this case is with XML style sheet transformation. This is another area pioneered by Casey Smith. He found a few techniques, a few ways to, he figured out a way to embed script code in these transform files. And what's interesting, under the hood, these actually abuse this NSXML 3 and 6 DLLs. These are the scriptos. So as an example, this was posted last year, discovered last year, this using Wimic to go out and fetch this remote XSL style sheet to then invoke and execute that scriptlet code. In this case, we're just simply launching another command processor. Very, very interesting attack. And some of these attacks actually at one point may have or have, in fact, bypassed device guard as well. So keep that in mind as Microsoft patches and updates that block rule list. So let's talk a little bit more about PowerShell. So PowerShell constrained language mode is very restrictive, but under another enforcement mechanism, or I should say an Apple control mechanism like AppLocker, there is no code integrity enforcement. So interestingly, we can actually abuse that new object commandlet and that COM object parameter to pretty much instantiate any COM object that we want. So in this case, I chose a COM object called Microsoft XML DOM. That's actually a very interesting one because that'll come back later on in the WDAC section. We'll comment on that as well. But here we use this and we leverage a method called transform node. We can actually take the XSL style sheet and call that function and execute that scriptlet code embedded in that XSL file. All right, so a couple of AppLocker resources. Odvar Mo gave a great presentation last year at DerbyCon. I highly recommend checking them out. And then Adam Chester at XPN wrote a really nice blog post on the PowerShell technique to bypass the new object commandlet. So let's talk about WDAC. So WDAC discussion would not be complete without talking about the Windows lockdown policy. Now, Windows lockdown policy is activated when UMCI is under an enforced code integrity policy. It actually it's implemented in a link library called WLP.dll, which is quite fitting, and it exports a function called WLDP is class in approved list, which is pretty much does the heavy lifting for validating whether a particular class ID is safe. And what this is that it does this by checking a list of approved COM class objects that are allowed to run on the respective system. And that's already predefined, typically, by Microsoft, somewhere in the OS. If you recall during COM activation, the prog ID is first resolved to a class ID, say if we're trying to activate that. Under UMCI, if the class ID is in the approved list, the activation is allowed, otherwise it is not. So at the bottom slide, I listed a couple ways to potentially go about looking for WDAC bypasses. And this isn't a comprehensive list. This is just a few ideas that I had or I've seen in the past. So not every script host out there is WLDP Enlighten, and Enlighten means pretty much a script host that actually is compiled with this WLDP.dll. But the last two we're going to cover, discovering unsafe COM objects that are in the approved list and reintroducing old code that is still trusted. So last year, a lot of great research by some great folks, very motivated. I took a class last year taught by Matt Graber, very, very great. It was PowerShell focused, but talked a lot about bypasses, and really got me thinking, okay, AppLocker is cool, but I need to step up my game and really look for ways that show more impact. And this was kind of neat. So this was sort of the driver for that. So the script stuff was neat, but the XML stuff really, really drove home for me. So I was, to last spring, I was poking around, and I ended up finding that there was a COM object called Microsoft.xml DOM 1.0 that is the prerogative for a class object that exposes some interesting functions. So I used a scriptlet like this to enumerate all of the actual COM objects that pass that approval check from WLDP, I'm sorry. So that object stuck out. So I queried those methods, and right off the bat, I saw these transform node methods and set property, and I was like, okay, this looks like a potential indicator for bypass. So I loaded up the XSL script that I had, and sure enough, as I executed, I was able to execute that scripted code right in the middle and actually invoke and actually instantiate a COM object that otherwise should have been allowed. So Microsoft patched this last November. They patched the bypass vulnerability and updated the COM server. And basically, that COM server is msxml 3.dll. So I tested that patch to make sure it worked, and sure enough, it did. However, in December, I actually was building a new test machine, and sort of came up with an idea. I'm like, what's interesting? I wonder if I could replace some of these things. So I actually pulled over a few versions of MSXML3 from previous operating system versions or different build families, and copied these over to the new WDAC machine. And interesting, one of those binaries were actually still signed. And what I found was, let's say like you take a build series like Windows 10 build 14783, right? So 14783.1 binaries. In this case, we're actually still signed by something like, build series 1473.476. So think about incremental patch cycle as time goes on. And a lot of stuff is actually stored in the Windows side-by-side directories. But, at the time, I was just trying to aggregate and copy as many files as I could over. So a deeper look into this actually revealed that it was catalog signed. And this gave me the idea, like, okay, well, that means Microsoft actually updated a patch, set a patch for this NSXML3 DLL, but they did not actually remove the thumbprint from this actual catalog signed file. So that was neat. So I took I decided that a COM hijack was probably the appropriate way to go about this. So I exported that COM object class structure from the HK local machine Hive, and then I updated the paths respectively for HK current user, and I changed the path to the inproc server 32 value to point to my outdated vulnerable MS-XML implementation. So import it back in, and immediately, because the HKCU keys override the HKLM, that showed up in the current root. So just as I expected, replayed the previous EV, and there we have it, code execution again. So I reported this to Microsoft and they pretty much decided not to patch the hygiene issue. They were going to patch it, but they ultimately decided to add rules to their block list. And you know, that's sort of, that's interesting, and that's fine. It mitigates maybe this particular attack, but you know, it still leaves the door open for other opportunities for abuse that might take advantage of this catalog hygiene issue. So, before going on to some defense, I only got a few minutes. I really want to give a big shout out to Philip Zuckerman. He's done some really great research recently for Device Guard. He had a talk at Troopers called Sneaking Past Device Guard. I highly recommend checking that out if you're interested in this area, as well as Matt Graber's and James Forshall's blogs. Really great resources for WDAC. All right, so a few defensive considerations. I'm pushing time here. So, you know, application control, most organizations don't implement it. If you do, that's a good start in the right direction. Highly recommend that you look into it. Some things to consider in PowerShell: upgrade to 5. Take advantage of those security optics. Take advantage of constrained language mode. You can also actually detect PowerShell COM instantiation events if you monitor for ID 4103. It's actually kind of neat. Furthermore, antivirus, make sure your vendor supports AMSI. AMSI is really growing in capability. There's exposure that AMSI has with event tracing for Windows, ETW. Matt Graber and FuzzySec have done some research in this area, and you can actually potentially pull out like the content of scriptlet code execution with these event tracing for Windows logs. So hopefully we'll see some more adoption of that in the future as well. But if you have a vendor that doesn't support AMSI at all, you might really want to consider finding an OAV vendor. Also, keep an eye on your AppLocker and your WDAC logs. If you see weird block execution events, it's probably a likely indicator of compromise. And for policy and rule improvement, there's a project called AppLocker for AppLocker. A really good way to boost your AppLocker rule sets. For WDAC, make sure you update the Microsoft Block rules list if you are implementing it. This changes from time to time, and keep your patches up to date. And of course, test the efficacy of your rules. There's some great frameworks out there, MITRE ATT&CK frameworks. You probably hear this a lot more for EDR testing. Well, they help with whitelisting protection as well, and also some other tools mentioned here. So that's it. Thank you all for coming to my talk, and thank you for bearing with me.